All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about TOML. Dude, I'm going to try my best to make this the last TOML stream because I mean it's not that big. I think for the most part we are actually done with TOML. Yesterday, oh shit, I accidentally left this open. Fortunately, this is not some sensitive information that I didn't want being shown on stream for whatever reason. This was a log from this actually this is connected to something else that I also oh shit, I forgot to vlog today. Dude, today was a great opportunity to vlog. I had the chance. It completely slipped my mind. Actually, there was a good reason why it slipped my mind. And okay, this is also reminding me that I need to, oh, wait, there. I need to do this maybe because there's a couple of topics that I want to talk about, and I feel like once I start the camera and start recording, I'm gonna forget some of the topics, and I'm not gonna be able to get everything out or record everything. Yeah, I'm not going to be able to get everything out. And then once the recording is over, maybe half an hour or 1 hour later, maybe even like 15 minutes later, I'll realize, oh shit, I forgot to talk about this, forgot to talk about that, and then it's going to be like, dude, give me a second. Okay, so um let's create a new thing here. Let's call it vlog topics. Okay, the first topic is GitHub um, GitHub Git workflow uh, has been set up. The second thing, see, already forgotten. Oh, TOML. I've been learning about TOML, and then everything surrounding TOML as well. What was the next thing? I can't remember what the next thing was. So instead, I'm just gonna jump to. And I mean, to be fair, I don't really want the vlog to be way too long. The whole idea is for the vlogs to be pretty short. The very first vlog, it was a little bit long. Fortunately, not that long. It was like maybe 13 minutes. But I am aiming for less than that time. Hopefully only a couple of minutes. And that's the end of the vlog. Okay, so this brings me to um, gaming on Linux. So today I tried out Metro 2033 Redux on on Linux, and initially there were a few issues, which was also why I kind of ended up starting the stream late because I had some troubleshooting to do. I had some issues to deal with. I installed Metro 2033 Redux and tried starting it up. Initially, I assumed that it would use Proton by default. Steam would use Proton by default. Proton is a compatibility layer that sits between your game and Linux, and it essentially allows you to run what is meant to be the Windows build of Linux. No, the Windows build of the game. It allows you to run that Windows build, but run it on Linux instead. So it more or less translates the calls. I'm still doing research on Proton to understand if there's something more than that it does, because I wanna get a better understanding of exactly what this compatibility layer is doing. I'm aware of stuff like GPU calls, for example, something that might be a DirectX call on Windows. The compatibility layer will then translate that to maybe a Vulkan call. So then it goes as a Vulkan call to your GPU. And similar to that, there's a couple of other things that it essentially translates a bunch of that stuff, basically working as a compatibility layer. And where was I going with this? Yeah, so initially I assumed that Proton would be running by default, but it wasn't. I guess I guess it tried to run um, whatever the Linux build is. I don't know if there is a Linux build. There might be a Linux build for it. Though this has me curious about whether, like, if it is installing the, yeah, wait, hold up. I have this question. I'm gonna ask Gemini the question right now because I'm I'm wondering if, like, it has to be that it's installing the Windows build itself, right? Because that's why it has to do the whole conversion thing. Let me check with Gemini. I hit the wrong key combo. Okay. Hey, so I'm trying to understand um, something about uh, gaming on Linux via Steam Proton. Actually, I don't know if Proton is built by words. Holy shit. I don't know if Proton is built by Steam. That's what I was trying to say. Sorry, zoned out. Okay. About gaming, so and so, so and so. All right. I'm curious if what I'm installing is the Windows build or the Linux build. Because, wait, okay. It has to be the Windows build, right? Considering that considering that's why there's a need for a compatibility layer. You nailed it. Your intuition is 100% correct. When you use Steam Proton to play a game, Steam is downloading and installing the Windows build of that game. Because it's a Windows executable file, Linux has no idea how to run it natively. This is exactly why Proton steps in as a compatibility layer. Here's a quick look at what happens behind the scenes when you hit play. The translation. Proton acts like a real-time translator when the Windows game tries to talk to the operating system, asking to render graphics, play audio, or read a file, Proton intercepts those Windows commands and translates them into Linux commands on the fly. The graphics magic. One of Proton's biggest jobs is translating Windows graphics API calls, DirectX 9, 11, or 12, into Vulkan, which is a high performance graphics language that Linux understands natively. Sorry, zoned out. Okay, the prefix wine bottle. What? For every Windows game you install, Steam creates a hidden isolated folder called a PFX, Steam prefix. Inside this folder, Proton sets up a fake Windows directory structure, completely complete with a mock C drive, program files, and a Windows registry. I didn't know this. I didn't know about how exactly Proton was working. I guess that other conversation that I was having with Gemini, in that convo, it would have been revealed exactly how this is working. But yeah, okay. So the game genuinely believes it is running on a real Windows PC. The dynamic exception. While you are right about Proton games, Steam does host native Linux builds for certain titles like Counter-Strike 2 or Stardew Valley. If a game has a native Linux version, Linux will usually download that by, oh, okay, and Proton won't even turn on. Okay, that might have been the issue because initially it wasn't using what do you call it, Proton, and that was part of the problem. Like I assumed that it was going to be using Proton, but it turned out it wasn't. So what ended up happening is when the game started, it started in a lower resolution. I'm on 1920 by 1080. So if a game is being displayed in full screen, the game will be it'll most likely be stretched to fit that 1920 by 1080 size, right? It's not going to be scaled up to that resolution. However, it'll be stretched, whatever the resolution is, it'll be stretched to fit that size, because full screen. Um, though I guess at that point it becomes less about resolution and more about the dimensions of the monitor, the dimensions of the screen. So, anyways, okay. Hold on. In correcting myself, I forgot what I was saying. I was saying that um, while I'm yapping, I can freeze the RTMP feed. Okay, now, okay, I can't remember where I was going with this, so I'll just go back to what I was talking about. Um, by default, it was not using Proton. Oh, yeah, I just remembered. So, when I started the game, it was occupying. It started in full screen, which is fine, but it was occupying maybe three-fourth of the screen, not the full screen. It was occupying only three-fourth, and the remaining portion was just all like glitching. It wasn't even like fully transparent. It was just glitching. Um, and I wasn't sure what was going on. I'd passed it the flags that are required to make the game use the NVIDIA GPU, and yeah, the thing it just wasn't working. So then I asked Gemini, and Gemini said that yeah, there's a chance that it's not using Proton. It's using something else. I went and checked, and then I found out that yeah, it was using I forgot what the thing was called, Steam something runtime. Was it native client, native runtime, something like that? It was codenamed Scout. I think it was one of their runtimes. Um, anyways, it was using that. I had to, first of all, I had to check a checkbox that said, use a compatibility layer, and then it showed me a drop down. By default, the um what do you call it? By default, the Steam runtime thing was selected. Proton wasn't selected. So when I expanded that menu, then I found a list of various Proton builds that I could use, and yeah, I picked the latest one and started up the game, and the game started up great. Initially, it was a little bit laggy because well, I'm running it on a low end system, but something interesting happened after the cutscene finished, the initial cutscene of the game finished. Before going into the main menu, the game automatically um, optimized the settings to be on like the lowest settings, and then I had a much smoother experience. Additionally, like once the game optimized it, things were a lot more smoother. But additionally, what I did is I went into the settings and turned down the resolution. It was on 1920 by 1080. I turned it down to like, I think 1280 by something. 1280 by 760 or something like that. I don't remember exactly, but it's not 1920 anymore. And also I turned off motion blur. One, because it can help, with performance, but also uh, over time I've realized that motion blur, it's not for me. I used to love motion blur in, like, back in the day, but mainly I liked it when I played racing games. So like Need for Speed, for example. I loved seeing motion blur in that, but in other games like FPS and stuff, it wasn't really my thing. Especially because like the amount of movement that happens when you're constantly looking around and there's a whole lot of motion blur going on, it's just not the best thing to keep looking at. Um, but yeah, I turned that off and then I started the game. Then another issue that I ran into was the Xbox controller, because I wanted to play using the controller, not using the what do you call it? Not using the keyboard and mouse. The issue I ran into with the controller was that it was not being recognized for some reason. I couldn't figure out why. Initially, I had connected it to the laptop through an extension, through a USB extension. It wasn't directly connected. And I tried a couple of things there. I tried getting help from Gemini as well. Gemini suggested a couple of things. Finally, I tried something else. I first tried disconnecting it from the extension and connecting it to another USB port on this laptop. For some reason, even there, it wasn't working that well. Working is like, let me explain. So it's a Xbox 360 wireless controller. This is an Xbox controller. You need a wireless receiver to, you know, connect this with a PC. And what was I saying? You need a receiver to connect this with the PC. Yeah, yeah. So what you do is you connect the receiver to the PC or laptop, and then the receiver connects to the joystick. And these joysticks, at least the older Xbox 360 controllers, they have four light quadrants, they call them. They have like four different lights on the controller. One of those lights will light up. It's arranged in like a ring, and four of them are arranged together as four. So like one fourth, one fourth, one fourth, and one fourth. Um, One of them will light up when your controller has actually been connected. If the entire ring is just constantly blinking, the thing hasn't been connected. So that's the issue that I was having. Finally, I disconnected the receiver from my laptop and connected it to my USB hub that I have connected to the same laptop. And surprisingly, it worked in that situation. I have no idea what's going on there, but it is what it is. The thing works. It's now being recognized, so I'm not going to complain about it. I am now slowly trying to get used to aiming using using a joystick. Aiming is the only thing that I need to kind of get used to, and maybe adjust the sensitivity of like within the game to kind of get to where I need to be in terms of in order to get to a point where I'm where I feel like it's an adequate speed of looking, and also it's giving me accuracy, which is great. And like, because okay, with the control sorry, with the controller, for looking around, you're going to be using the right analog stick. And because it's an analog stick, you can control um, the speed of the look. So you can either look slowly. So if you just bend the stick a little bit, you'll be looking slowly, you'll be turning slowly. If you bend it fast, then you'll be turning fast. I also think my analog stick might be going bad. This is a pretty old joystick. I've had this for a while, and over time, I don't even think it's through use. I think it's just maybe there's like dust inside it. So something I could do is maybe I could open it up myself and try to clean out the joystick. I've never opened an Xbox controller before. Um, and in general, I'm not used to opening things and then fixing something in them and putting them back together. As weird as that sounds, it kind of sounds like I just break things. But honestly, yeah, I just break things. There have been some situations where I opened up something like, for example, there were a lot of like old home appliances that I had. Like a couple of months ago, uh, I was doing like a cleaning of my room, and I for years I had this habit of just holding on to and hoarding, essentially hoarding electronic devices, because the belief was that, oh, at some point in the future, when I have some time, I'll open this up and I'll study it. Um, for the majority of the stuff that I held on to, that did not happen. That just did not happen. And I just kept holding on to it until finally one day I was like, dude, let me just throw this out, because there's a lot of stuff here. It's taking up a lot of um, it's taking up a lot of space in my room, and it's also contributing to blocking the airway, the airflow of the AC, so there isn't like as smooth of an airflow. But additionally, it's also contributing to the overall thermal overall heat in the room, because each of these, everything that you put in your room, it has thermal mass, and that's the ability of this whatever object it is to hold a certain amount of heat. And these objects are continuously exchanging heat with the air itself, which is why if you have too many of these objects, any cool air that your AC is blowing out and blowing into the room, a good chunk of it could just get distributed into these objects, and it's not going to do that good of a job of cooling your room. I learned that, and because of that, I started actually clearing up my room, and that's been beneficial because that has helped me in many ways. It also made me realize that I'd been hoarding a little too much. I still hoard like a little bit, because dude, older electronic devices, especially if you are into hobby electronics, you want to hold on to some of these things. At some point in the future, you might have need for them, but you need to know where to, put a limit to it. And in my case, the reason I had to put a limit to it is because my AC wasn't cooling the room nearly well enough because of all the stuff that I had lying around. Okay, anyways, back to uh this. I started playing Metro 2033, and so far it seems to be going well. I haven't been seeing a whole lot of lag, which is great. I've kept the settings at like the minimum, and yeah, I'm looking forward to playing this game later on, maybe after the stream, or I don't know, maybe tomorrow, before tomorrow's stream or something. Okay, all right. Oh, wait. Give me a second here. I need to. Okay, now let's start up the RTMP feed again and come here. Wait, give me a second again. Okay, sorry about that. I was just looking into something. So this is done. We can go back to this and come here. Okay, right. Um, what was I saying? Yeah, so I mean, I'm looking forward to doing some gaming on Linux. Things seem to be pretty decent so far. I am monitoring the GPU temperature, which it kind of sucks that I have to do that, but yeah, I'm keeping an eye on the GPU temp. I probably should also um, start using I have this fan attached to my laptop. It's like an external fan that I attach to a crate, so I could then place the laptop on top of the crate and then and cool the laptop in that way. I guess I should start turning that on so that it's constantly cooling the laptop while I'm gaming. Um, okay, I guess let's jump into TOML. So between yesterday and today, in fact, after yesterday's stream, I was looking into towards the end of yesterday's stream, we were exploring how to visualize the data that I'm writing in TOML for the sake of um, learning. I wanted to be able to visualize the data that I'm writing in TOML, and turns out this is a pretty decent way to do it. It's just it's literally just three or well four lines of code, and I'm able to get the data in JSON form. This is what this is doing is, at least from what I understand, it's reading the TOML data from the file and storing it into a string, and then that string is being passed into the from str method, which is this. And I think this is where because I was having a conversation with Gemini about why I had to specify the type over here. I had to type annotate the um, what do you call it? I had to type annotate this variable that was created. I believe it has to do with, wait, what just happened? Why is there nothing for this? Why does from str not have, okay, why was, okay, that was confusing. Anyways, I believe the issue is, or not really an issue, it's more of a generics thing here, which is why you have to specify the type that that this function is going to be returning. The function is basically this: you pass in a string. The string in this case, because it's the TOML crate, so the string in this case is a TOML string. I believe this then serializes it to, or deserializes the TOML string into um, the CRD data model, the CRD intermediate representation. That's what they're calling the data model, and then from there it gets converted to whatever other uh, whatever other type you want. Um, sorry, I didn't really say that, but from there that gets converted into whatever language. You want, how does, wait, no, how does JSON connect here? I just realized that, like, now that I'm thinking about this, you know what? Wait, instead of guessing, let me go back to the conversation that I was having with Gemini, and Gemini can then clear it all up. Um, okay. All right. Hold on. I'm just reading this conversation because at one point Gemini did suggest this code, and that's kind of how I know about it. And then I asked a question. Okay, so I asked Gemini about this. I asked Gemini about this line specifically. This line where I had to mention the type. The type is CRD JSON value. So this is from the CRD JSON crate. This is the JSON crate that is CRD compatible. So here we are using two crates. We are using TOML, which is CRD compatible, and JSON, which is also CRD compatible. The interesting thing here is that we are converting TOML from string. We are converting the TOML data from a TOML string into something. In this case, we seem to be converting it into a JSON value, which conveniently we are then able to pretty print, and that's why we're able to get this information. But I wonder, what if we were not converting it to a JSON value? Then what exactly would be, or what exactly would we be? Because then I feel like then we would have to provide our own struct, right? If we are able to provide, what are the constraints here? I forgot what the term is for that. Um, yeah, I think it's type constraints, right? I I, I forgot. Uh, from string. Okay, all right. T value. T equals value. Uh, where T is deserialize. I think for this also I'm gonna have to ask Gemini. Okay, so here we have a deserialized thing. Okay, deserializes a string into a type. This function will attempt to interpret S as a TOML document and deserialize T from the document. To deserialize TOML values instead of documents, see value deserializer. Okay, for me it's a document, so I'll stick with that. Oh, okay, so then I'm gonna have to reconstruct the entire thing. So if I attempt to do something like, wait, how do you do it? Is it this? Yeah, it's this. Um, Hold on, I'm missing something here. Do I have CRD installed? I mean, I haven't explicitly installed CRD, but um, okay, is it? Okay, let's try TOML, deserializing TOML into Rust structure. This is a module. Okay. Oh, um, definition of a TOML. Maybe it's not this. This is just a module, right? Okay, but then so is this. Wait, okay, instead of guessing, I'm gonna ask Gemini. But first, let's read what Gemini is saying here about this. Okay, so this is an excellent question. Specifically, what I was referring to is this line where we are using toml.from_str to convert the toml string into a JSON value. Now, from str, it returns a generic, and so the compiler doesn't know what what the type is supposed to be. That's why we need to annotate this variable. The result that's then returned is this, and well, what's returned is the result. From str returns a result containing either the value or the error, or an error, and that's why we use unwrap to get the value. So Gemini is explaining it. This is an excellent question. Line 2 is where the real Rust type system magic happens, and it can definitely look a bit strange if you're coming from a language like Python or JavaScript. Here's the line in question. Okay, you have to provide that CRD JSON value type annotation because of a powerful Rust concept called generic return types, combined with how the TOML crate handles deserialization. Okay. TOML from str doesn't know what it's making. Yeah, I figured that was the issue. And this is also why we have situations where we need the silverfish, sil turbofish. I keep saying silverfish. This is also um why turbofish syntax exists. So I need to try and remember how to do that, because here, how would I use the turbofish syntax here? Hold on, let me copy this and open up a new conversation. Hey, I'm learning um TOML and am using Rust to deserialize deserialize TOML. In this line, how would I go about using the turbofish syntax? To use the turbofish syntax here, you need to attach the type argument to the from str function. Okay. In Rust, the turbofish looks like so-and-so and sits between the identifier and the opening parentheses. Oh, so yesterday when I was trying to do it, I was inserting it here. I was doing this CRD JSON value, and that was giving me an error, rightfully so. Actually, wait, get rid of this. So it actually gives me the error. Yeah, there you go. I need to instead attach it here. Okay, cut that, paste. Yeah, there we go. Now we are using the Turbofish syntax. All right. Okay. I need to remember that it has to sit between the identifier and the opening parentheses. But yeah, okay, going back to Gemini explaining how this is working. Okay, so from str doesn't know what it's making. The TOML from str function is completely generic. It doesn't inherently return a JSON object, a Rust struct, or a Python-like dictionary. Its function signature looks something like this. You know what? We could look at the definition here, right? What was I forgot. I think it's through this and, okay, incoming calls, type definite. Wait, what happened? Oh, yeah. Um, declaration, type definition, references, definitions. Okay. From str, this might be a trait kind of thing, right? Okay, this is going to a different function, deserializes bytes into a type. Oh, is it just calling this? No, no. Damn, dude. I don't know why I suddenly start getting sleepy when I'm like thinking a lot. That's wild. I need to look into that. This is this is weird. But anyways, okay, so I'm gonna have to dig a lot here. So I don't think I'm gonna do that. Instead, I'm just gonna continue looking at Gemini's definition. Okay. So the words, the definition that Gemini gave me is this. I'm gonna drop it in here, and we can. Um, hold on. That's interesting. Okay, I never looked into that aspect of the. Yeah, I should keep that in mind. Also, would go to definition immediately jump to that? I wonder. Let's delete this real quick and try doing goto. I have not used goto nearly enough in NeoVim. So if you hit G, you get this goto which key menu, and there's a bunch of options in here. Um, commenting is one of them. So usually you do GCC to comment, and also GCC to uncomment. And if you are in visual mode, and let's say you have, let's say these two lines selected, just GC is fine. Okay, now coming here, let's see if it's able to go to the definition. So we have definition, declaration, and implementation. Signature help, we already have that Shift K. References. Okay, so let's try going to the definition. I should start doing this a lot more because I already know that we are gonna have an LSP symbol table kind of thing. That's what this does. So if I do space C, if you look down, wait, are you guys able to see the last option? Anyways, the last option says S or uppercase S LSP references. So that's what oh, I just enabled, I think it's the Arial symbol browser thing. So let me just close that. This is very useful as well. This is useful in its own right. This symbol thing. So I can like, let's say select this and uh, then it'll jump there. If I'm in the buffer that the symbols are being displayed for, as I scroll down in the code, you'll notice in the right side the symbols are being highlighted, right? But if I'm in the symbol menu itself, I can select any one of these and hit enter and jump to it. There was also a way to jump to the different symbols in this table. I can't remember what that was. I'm gonna have to look into the shortcuts of the Arial browser. Maybe maybe it's this is just Arial toggle. Dude, this is a nice fuzzy finding trick that I learned. In fuzzy finding, this may not apply to like all fuzzy finding applications, but like in general, the fuzzy finding technique, for the search patterns, they have like specific symbols that you can apply within the search pattern. And in this way, because this is essentially fuzzy finding, and so it's giving the okay, I don't know if this search is specifically fuzzy finding, but if I type Arial, it'll give me Arial, but it'll also give me other stuff. You can see other options being highlighted where there's A, E, R. So it kind of gives me various different options. But if I add an apostrophe at the beginning, then if I remember right, then an apostrophe at the beginning is to signify that in this pattern, this word has to be whole. We are not looking for individual alphabets. We are looking for this word whole. But yeah, okay. Anyways, that was a bit of a tangent. Let's close this, come back here. Okay. Um, right. So notice that, oh yeah, in the thing that was returned, well, okay, this can give an error for now. That's fine. So Gemini is saying, notice the T. This means, yeah, from str can return any type. That's a generic. Yep, understood. T is the entire universe. No, from str can return any type T in the entire universe as long as the type knows how to be deserialized. I guess that's where this part comes in. Deserialize owned, or maybe rather I should show it here. Yeah, I guess that's where this comes in. Okay, because from str is a blank slate, it looks at you. What? Because from str is a blank slate. It looks at you. Oh, it looks at you to tell it what target type T should be. Okay, Rust infers backwards from the variable. Rust has powerful type inference, but it can't read your mind. If you just wrote so and so, yeah, that makes sense. That makes sense. Because the compiler doesn't know what type you want this to return to. Um, it doesn't know that it doesn't know exactly what you're trying to store this value as, because holy shit, what it is returning is a generic. All right. The compiler will scream type annotation needed. I don't know what you want me to turn this TOML into. By adding so and so, which now is our turbofish, which now is specified in the turbofish syntax, you are giving the compiler a destination. Rust looks at the variable type, works backwards, and says the user wants JSON value to be a CRD JSON value. Therefore, I must tell TOML engine to parse the text directly into JSON structures. Okay, okay, all right. The power of swapping the type. To see why this design is so brilliant, look at how the exact same function call behaves if you change only the type annotation. Okay, scenario A, parse into generic JSON. Scenario B, parse into a strongly typed struct. That's what I was about to ask next. Scenario C is parse into a hash map. I did not think about that. I actually did not know that I can do that. Is that even possible? Can I just um okay, yank, paste. Here let's do hash map. Uh Hash map. What is it? I'm just gonna say string string. I don't know if it is exactly string string. Um, okay. Are we good now? I think we are good now. Now, would this know how to... Oh, this is gonna give us an error. Wait, wait. Yeah, yeah, no, no, no. Hold on. What we're gonna do is say hash or hmap. Yeah, that's better. So now we're gonna do print line. Okay. Uh, so and so hmap. Oh, does it need the debug thing maybe? Yeah, it does. Okay. Now let's see if this even works or if it panics. Yeah, there was an error. Invalid type, sequence expected a string, um, input so and so. Yeah, I had a doubt that something like that might happen. The reason is because let me show because not all of it is strings. Actually, that's part of the problem, isn't it? Not all of them are strings, because we do have like nested dictionaries. Yeah, that could be it. So if you look here, this is our JSON data. Sorry, this is our TOML data. Um, all of this, all of this is our TOML data, right? Um, all of this is our JSON data. So we have an integer here. What? So let's look at some O1. Hold on. Oh, okay, there it is. I was about to say that I'm not seeing some O1 being mentioned here, but no, some O1 was mentioned. What's interesting is that it is within, so we have this, right? But then what is this? Oh, that's for the table. Yeah, okay, I get it. So anyways, back to what I was saying. It's not always going to be, key value, and both the key and the value are strings. That's probably why the hash map string thing is not working, because it's not always going to be string. All right. Okay. Now this has me curious about, okay, let's try something here. Okay. We have this. Let's create a new thing called sum toml o1 dot, actually o2 dot toml. In here, let's create only, yeah, so let's say sum o1 equals sum val o1. Okay. All right. Okay. Done. Now, um, oh, maybe let's increment here as well. Dude, I love this incrementing plugin. It is so convenient. I can very easily increment. I can also decrement. Oh, I just noticed that it got rid of the, oh, it respects the zero as long as we don't end up occupying the zero. But then once we occupy the zero, once it has become a two digit number and we try to go back to one digit, it doesn't bring back the zero then. Okay, that's good to keep in mind. Right. Now, if I try to do this same thing now, would this work? I'm trying to think about how this would work, because even now, no, this should be a hash map, right? This should, what I've defined here is basically a hash map. Yeah, this is essentially a hash map, so we shouldn't have any issues here. Yeah, yeah. That is our hash map. The entire TOML thing, it very easily deserialized. Dude, this is crazy. We are just able to pass generic types and have this thing. This like hash map doesn't even have anything to do with CRD. And I was able to pass in hash map into from str. Well, not pass it into, but like provide hash map as the return type for from str. That's crazy, dude. Okay. Okay, so this is wild. Um, I'm surprised that I'm able to just pass hash map string as the return type when hash map has nothing to do with CRD. Also, if I wanted to um, pass in a custom struct, what or how would I go about doing that? Keep in mind, all I have installed is TOML and COD JSON. Okay, here's a breakdown of why HashMap works out of the box and exactly how to set up custom structs. Why HashMap works, the secret behind COD. You're completely right that HashMap is part of Rust's standard library and knows absolutely nothing about COD. However, COD knows about the standard library. When the creators of COD built the crate, they wrote blanket implementations for almost every common type in the Rust standard library. Deep inside the COD source code, there's literally a line that looks like this. Let me paste it so you guys can see it as well. Um, Actually, let's create a scratch file. Yeah, this is what it looks like. Wait, impl so and so, where so and so. This is a trait. No, oh, there you go. Impl deserialize, which is the trait for hash map. All right. Okay. Okay. Because CRD explicitly teaches hash map, vec, string, option, and integers how to deserialize themselves, the TOML crate can instantly plug into them. How to use a custom struct. If you want to use a custom struct, your current setup and your current setup, which is just JSON, just TOML and CRD JSON, won't quite cut it. To use a custom struct, Rust needs to generate code at compile time that teaches your unique struct how to translate itself from JSON's data model. To do this, you must add the CRD crate directly to your cargo.toml and turn it and turn on its code generation feature, derive. Okay. Oh, I need the feature as well. Um, right, let's I don't have to do it from here. I can do it from here. Cargo add. Okay. Features derive. Is that all I need? I think so. What is the difference between derive and CRD derive? I should ask that question. Oh, let's also do a cargo build so I can then directly open up NeoVim and it'll load up the all the IntelliSense related stuff. Okay, that's done. Open this up and okay, now it's loading stuff. Okay, right, update. Okay, and then the code. For the code, we want to use CRD deserialize, which is imported from your new dependency, and pass that into config. Well, config is the name of the struct. Okay. I guess in a way, this has also answered the question that I was having, which was what if I just create a struct that only has one field, but then what I'm expecting it to return is the entirety of that. Um, oh, wrong file. Hold on. Um, okay, there. So if I'm expecting this this entire dictionary, because this whole thing is one dictionary, right? This would be no. Yeah, yeah. No, no, no. Yeah, that's true. This entire thing would be considered one dictionary. The interesting thing though is that in this case we wouldn't necessarily consider this a hash map. However, I feel like we could technically reconstruct a hash map out of this, but then the type thing becomes a little complicated because, okay, so this dictionary has, going from the top, it has an array or a list, right? It has another array. So first it has an array of, or I should say each entry, each key in this dictionary going one by one with the keys. For the first key, the value is an array. In For the second, sorry, zoned out. For the second item, for the second key, it's also an array, but the first array is an array of integers. The second one is an array of strings. The third one is a dictionary of itself, I think. Yeah, yeah, I believe. Yeah, the third one is its own dictionary in which the key here is a string. The key's value is a string. The fourth one is a dictionary containing a dictionary containing a dictionary containing a key whose value is a string. And then down here we have another key whose value is a string, another key whose value is an integer, and then another key whose value is a dictionary containing a key whose value is a string. All of this, trying to put it into a hash map would be a little complicated. And that's probably why it's going to throw an error as well, because it's not able to convert to whatever the type is, right? Yeah, yeah. I need to continue reading up on this. I mean, okay, I don't need to, but this is words. Holy shit. This is one of those things where this is one of those situations where I need to um explore Rust's generic type system more, or generics, Rust generics. I need to explore Rust generics a lot more. Um, but also I'm mainly trying to get an understanding of how things are working on the CRD side. I guess if I did create a custom struct, um, which is kind of interesting, that JSON value is just able to handle all of this, right? But if I did it, I would need to create a custom struct. In that struct, I would need to have a generic type. How would that wait? How would that work? The custom struct would be a generic type. Wait, would that work? Hold on, let me see what Gemini is saying. Gemini hasn't used like Gemini hasn't used a generic type here, but okay, what's returned is a vec or a string. Gemini was mentioning this, right? That CRD has taught some of these types how to deserialize. So a hash map, a vec, a string, an option, and integers, right? since a hash map knows, and yeah, okay, then in that case, what we can do is, um, wait, wait, because what I'm imagining here is that we would be doing something like, um, let's say, I don't know, derive, deserialize, and then in here we're going to say sum O1, whose value is t, where t, I forgot how you specify. Okay, where t, um, where t implements deserialize, I guess. I don't know if I have to specify like a lifetime thing. Is that necessary? Oh, yeah. The type for this would need to be, um, yeah, no, this is going to get complicated. Hold on. What if I had um, the following? I'll just, you know what I'll do? Yeah, let me just copy this entire thing. Is it this? Oh, yeah, yeah, it's this. Dude, it's, hold on. This is crazy. Look at, wait, okay, let me yank this. Look at the difference between how it looks in TOML and how it looks in JSON now. Granted, in JSON, there's like, it's going to the next line and all of that stuff. But look at the difference between the TOML version and the JSON version. Holy shit, dude. In terms of human readability, I would definitely say TOML is a lot more human readable. Okay, what if I had the following TOML? Let's paste that, and okay, this is a great example because it showcases two of TOML's most interesting features, native dates and nested dotted keys. If you run this specific TOML through your Rust CRD pipeline, here's exactly what it spits out as JSON, oh, followed by how you would build a custom Rust struct to match it. So let's take a look at, okay, my mouse just died. Give me a second. Hold on. Okay. Okay, so for a custom struct, this is what Gemini is suggesting. Oh, yeah, we create a separate struct for everything. For every single dictionary, we need a separate struct. That's crazy. But wait, hold on. The names have to match? No. Oh, no, no, no. The names don't have to. Well, the names kind of have to match. The names. Hold on. Wait. So the fields, um, the names of the fields in the root struct must match what's in the TOML. Yes, by default, they must match exactly. If your TOML has a key called sum01, your Rust struct field must be named sum01. If there's a typo or a mismatch, COD won't know how to bridge the gap and the parser will throw an error. Now that I think about it, yeah, of course they should match, right? Because it's not being done based on like index. For some reason, I was assuming it. For some reason, just subconsciously, I was thinking it was index based. But now that I'm thinking about it, it's like, no, it has to match. It has to match. In fact, I think even in C sharp, when you're deserializing JSON, you have a similar thing. The fields they have to match the fields that are within the JSON. Otherwise, it's not going to work. You don't have this problem on Python because you don't really have to define a type in order to get JSON data. It'll just give you a dictionary filled with a bunch of dictionaries, and you can query whatever value you want. Okay, okay. You know what? I need to continue reading up on this and understanding this. Though I feel like I'm not even spending. I mean, in terms of trying to understand this, yeah, fine, sure, great. Um, I well, now that I know about this, now that I know how to do the custom struct thing, I will be able to use TOML in my other projects. That was the whole point of this. I wanted to be able to use TOML, and I actually need to use TOML in a couple of projects that I have planned. One of them being the dot files project. There, I want to specify a path or a list. Sorry, a list of paths. Not even a list, not even like an array. I think I can just do it as like a dictionary type thing. And though I do have the option, I can pick whichever one I want. Yeah, there's that too. I can just pick whichever one I want because it's supposed to be a list of paths. I have to see how I want to format that because TOML does give us a couple of different options, a couple of different ways to, you know, present your data, package up your data. So I can see which one works best for me. But yeah, okay. You know what? That's gonna be it for today's stream. Um, Holy shit, dude. I need to get better at like time management. Tomorrow I'll try to start the stream earlier. Hopefully tomorrow I also remember to do the vlog because I was supposed to do the vlog today, but then I got busy with all the troubleshooting. Um, Fortunately, the troubleshooting was just like an initial thing because I haven't played games in general, like not a whole lot for a while. And especially gaming on Linux, this was like the first time. So there was a bit of an initial troubleshooting that I had to do. Now that I have everything set up, I can just straight up start the game and I'm good to go. But yeah, okay. That's gonna be it for today's stream. I don't think I'm gonna be raiding anyone. I have some stuff to do, so I won't be able to stick around after raiding, and that's why I don't want to raid today. Maybe we'll raid tomorrow. I haven't been raiding a whole lot. I should raid more. But yeah, yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.